Okay, so today we're going to talk about powers, factors, and exponents. Okay, we're going to need these. We're going to need to know what these words mean. We're going to need to know how to, when we have exponent, what does that mean? How can I simplify exponents and things like this for our whole course. Okay, and this is something that you should not be forgetting. You should keep in your mind because you're always going to see it. Okay, so we're going to start with factors. What does the word factor mean?
The equation?
So let's say if I'm telling you 12, what would be a factor of 12? Give me. 1 is a factor of 12.
2 is another. 2.
2? 2 times what gives you 12? 2 times what gives you 12? 6. So 2 and 6, they're factors.
One of the factors that you can do in order to multiply in order to get to that number.
So it's 2 numbers that multiply together to give you 12, right? We call them factors, right? So if I'm talking about 12, right, there's 1 and 2, right? So 1 and 12, they're both factors of 12, right? 2 and 6, they're a factor of 12. What else? Give me another factor. 3 and 4. They're a factor of 12. Right? So when in a multiplication question, the terms that are multiplied together are called factors. Okay? But they're factors of whatever answer you're getting. Okay? So let's look at, for example, 20. What would be the factors of 20?
10, 2.
10 times 2. What else?
20 times 1.
20 times 1.
4
4 times 5. Right? These are all factors of 20. Now, not only these, also if I take negative 10 times negative 2, does that give me 20?
Yeah.
Yeah, because negative times negative gives me positive, and I'm still having 10 and 2. So negative 2 is also a factor of 20, okay? And negative 10, right? I can also take the negative 20 and negative 1, right? They're also factors. You can also have negative 4 and negative 5. Right? That gives you 2. That gives you 20. Okay? So factors are 2 things that multiply together to give you the 20, or to give you the answer.
Can there, what if the answer has 3 factors?
Sorry?
What if, is there only just 2 factors, or can it be more than 2 factors?
So if I ask you to list the factors of 12, you can list them like so. So the factors of 12 are 1, 2, 3,
I mean, no, like.
4, 6, and 12. So these are all the factors of 12.
What I mean is like.
Like the answer?
Like 3 multiplied by 3 multiplied by 3.
No. That won't be, they won't be factors, right? You can't, this will not, we won't call them factors, okay?
So factors is just 2.
It will be 2 numbers that multiply to give you that answer.
Okay, strictly just.
Yeah. Okay? So if you want to list them in order, you can list them in order or not in order, up to you. But these are like the list that you see right here. So I have 1, 2, 3, 4, 6, and 12. Okay, these are all factors. Are you guys okay with this?
It's always like a whole number, right? No, like one
Yes,
number?
it's a whole number. It has to divide completely. It has to divide to a whole number. Okay? Now, a repeated multiplication of equal factors, the same number can be expressed as a power. So, if I have 3 times 3 times 3, I can write that as 3 to the power of 4. Okay? So when you see this, you know that it's actually 3 times 3 times 3 times 3. 4 times.
Okay.
Okay? So anytime you multiply anything by itself so many times, you can raise it to the power. Okay? So let's take 11. So if I have A times A times A, how can I write that as an exponent?
A to the power of 3.
That's exactly it. A to the power of 3. Okay? On your calculator, you will see there's different things on the calculator. So take out your calculator for a minute, please.
I don't have.
You have a phone calculator?
Oh, yeah.
Yeah. So on the calculator, the power button would look like this. You'll either have a hat, like a, I don't know what you call it. That's a power button. Or you can see something that looks like this, x to the power of y. That's a power button. Or y to the power of x.
I see x to the y.
X to the power of y.
Yep.
Yeah, that's your power button. Do you see that hat?
Oh, yeah. X.
And if it's on your phone, you might have to move it sideways. I mean,
That's the power of y.
yeah, x to the power of y or y to the power of x.
Y to the power of x.
Yeah. And you can also see a hat. Yeah. These are all
Right.
the things.
Different
Move
on
it.
Apple versus iPhone.
Yeah. Okay. Gavin? You know which one? So if you want to enter on your calculator, can you do 3 to the power of 4 for me?
How do I do it?
So you do 3, hat, where's the,
Tell me 81. That's not right.
this one, x to the power of what?
X and Y.
Yeah, put that, and then 4. It is right. Equals, should be 81. Yes.
That's your symbol?
Yeah. Yeah, it is 81. You don't have to put the bracket. Did it put the bracket for you?
Yeah, give me that
Okay.
answer.
That's fine. So, when you enter it on the calculator, you're going to enter it as 3, and then either the hat or xy or yx, whatever your calculator say, and then you're going to put 4, and the answer should be 81. Okay? If you do it regularly, like 3 times 3 times 3 times 3, you will get exactly the same answer. Now, we're going to have to learn how to do the power button, because what if you have 4 to the power of 6? Are you going to actually sit down and do 4 times 4 times 4 times 4 6 times?
No.
And lose track of how many times you've answered it? No. So we have the easier way, and that's what we're going to use. Okay?
And so the hat is the X and Y, right?
Yes. So you either have, it's one of these 3 options on the calculator. It's either the hat, or x to the power of y, or y to the power of x, depending on what the calculator that you
You
have.
normally have all 3 or 2 or
No,
one?
it's 1. Yeah, you'll only have one of these 3 options. Okay? So what I want you to do is on the calculator, I want you to find 6 to the power of 3.
What was this one?
6 to the power of 3.
216.
216. Okay? Now, how do you think I should enter this on the calculator? What should I do? So I have 3 to the power of 2 times 2 to the power of 3.
That's the sum first. So 3 to the power of 2.
Yeah?
So that, and then we times it by whatever to the power of 6.
That's great. So I want to do 3 to the power of 2 first. Find the answer for that. So what do you get for 3 to the power of 2? 9. And then you're going to have to do 2 to the power of 3.
72.
The final answer is.
Oh.
So 2 to the power of 3 is 8, right? Then you're going to do 9 times 8, which is 72.
So 2 to the power of 3.
Yep. That gives you 8,
Okay.
right? And then you're going to do 9 times 8. So what I did here is the first thing I did is I found 3 to the power of 2, which is 9. Then,
72, right?
sorry?
72.
Then find 2 to the power of 3, which is 8. And then multiply the 9 times 8. Did it work?
It's 72.
72. Yeah. Okay. Now this is where the calculator can be useful, but at the same time can make mistakes if you don't enter it properly in your calculator. Okay? So this is where we're going to next. I want you to do something for me. I want you to enter -3 squared. And tell me what you get. So on the calculator, I want you to enter -3 and then to the power of 2.
Mine will let me enter negative, so what do I do for that?
There's a negative button that you should use.
Like another one? An alternative one?
Yes, there's this one.
Minus 9.
So you got 9, he got -9,
Oh, it's just the bracket comes first, so I can just do the bracket first, but that just doesn't count, right?
and that's why I don't like these calculators because they put brackets for you initially.
Oh, yeah?
You should tell the calculator I want brackets. The calculator should not tell you that you want brackets.
I downloaded another app, so
So let's use that.
try that one.
Try that
instead.
one. What did you get? -9.
What am I supposed to do?
-3 to the power of 2.
Uh,
Did you try it? Okay, did you try it on your phone? Okay, you guys try it?
I got a -9.
-9?
-9.
-9. Why do you get +9? You put -3 in brackets.
No.
So show me what you did.
Oh, this one's like.
Because your calculator is actually putting the brackets for
Negative
you.
9.
Oh.
Okay?
Negative 9.
-9. The answer should be -9. Okay? There is a difference between this and this.
Oh, was the calculator thinking that we're doing the second one?
Yes.
Okay.
So now try this on the calculator with the bracket. You should be able to have brackets and you should be able to put it in the bracket. So look for your brackets.
I can use 2 units, like
Yes.
brackets.
Yep.
9.
+9.
Yeah.
And I'm gonna putting it 9.
9.
9.
Do I do the power before the 2 or the power after the 2?
Power before the 2. Calc EQ7.
9. Look, it's doing
9?
double brackets, so let me know about that.
That's fine.
Okay.
Yeah. We all got +9?
Yeah.
This one. Okay, now, why did this one give me a -9 while this one gave me a +9?
Because of the brackets separating the number, which is,
So the brackets have to do something with it. Now, what's the difference between, so remind me, what does something to the power of 2 mean? What does it mean? 2 of it multiplied together, right? So in this case, right, I have 2 what? 2 3s or 2 -3s?
-3s.
2 3s because I don't have the bracket.
Oh.
Okay? So that 2 is only to the power of the 3. It doesn't include the 2. In this case right here, the second case, that bracket tells me that I have -3 multiplied by -3, and that's why I have the bracket. Okay? Because it's the -3 that is squared. In this case, I have a negative, right? That's it. And then the 3 is the only one that's multiplied by itself. Do you see the difference?
Not really.
Okay, pretend that I don't have that negative, right? What do you have here?
3 times 3.
3 times 3. 3 to the power of 2, which is 3 times 3, right? Now it's also multiplied by a negative, okay? So I put that negative outside, all right? Now in this case, I can't hide that negative because then I'm hiding the other half of the bracket, okay? So this is telling me that the whole negative 3 is squared. So that means I'm multiplying negative 3 by itself, which is negative 3. You see the difference?
Yes, I'm getting there.
So this, let's say if I have 4 squared, right? That's 4 times 4, right? Now if I do this, the only thing I have to do is add that negative outside, okay? Because that negative is not affected by the square whatsoever, okay? However, if I have this is telling me that it's the negative 4 that's squared, which is negative 4 is multiplied by itself, right?
So before the whole thing that was squared was for the power of 2, and now it's just for the 4, correct?
That's right.
Okay.
You see that?
Yeah.
Okay. So looking back at the 3's, right? What's negative 3 times a positive 3? What do you get?
Negative.
Negative 9, and that's why I get a negative here, right? However, in the second time, I have negative 3 times negative 3. What am I going to get?
Positive.
Positive, and that's why. So the bracket is going to make a lot of difference if you put it or you don't put it, or if it's there or not there. Okay? So when you're using your calculator, you have to know that you are using it correctly. Otherwise, your answer is not going to be correct. Okay?
So the brackets mean that all the 3's that you kind of divided in the beginning.
By itself.
Okay.
So this means that it's the negative 3 that is squared. So you're going to have to multiply the negative 3 by itself, which is negative 3. Okay? Just make sure that when you're entering it into your calculator, you enter it exactly the same way it shows on your sheet. Okay? So you're not making that mistake. So if there is a bracket, make sure that you put that bracket in the correct spot. Okay? So I'm gonna say this is negative 9 and this is 9. So let's look at the next one.
Do you mind moving it over just like a little bit so I can see what's on the right there? Perfect, thank you.
So we're going to move exponent law. The exponent law, if you're looking at this question right here, so I have 2 to the power of 3 times 2 to the power of 2. Okay? What does 2 to the power of 3 mean?
2 multiplied by
3
3
times 2.
2 times 2
times 2.
6.
times. Okay, so that is this one, right? Then I have times, because that multiplication right here. And then 2 to the power of 2 means what?
2 times
2 times 2. How many 2's are multiplied together?
5.
5. So that's going to be 2 to the power of 5. Same thing as writing this. Huh? Guess what? There's an easy way to do this. Okay? So the rule says, if you're multiplying two things with the same base, so the base in this case is the 2. This is the base. Okay?
Yep.
They're the same base. What you can do is you can add the exponents. So if I add 3 plus 2, that equals to 5. So that's going to be 2 to the power of 5. Let's look at a letter. Okay? Sometimes a letter makes a little. Can I move a little bit and then I'll come back?
I'm done, thanks.
Okay. So if I have 4 times a to the power of 3. Okay? Do I have the same base? What is it? The base is a. The base is a. So the base is whatever is the bottom letter or number. Good. Now, if I want to expand this, that's a times a times a times a, correct?
Yeah.
And then multiplied by a times a times a. You guys agree with me, right?
Yes.
So that altogether is a to the power of 7. Okay? If you look at this, since I have the same base, I can keep the base and add my exponent. That would give me the answer. So I don't have to do all of this.
Oh, so you have to, if you have the same base, you just gotta add the two numbers on above the A.
But you have to be multiplying, right? You have to be
Multiply,
multiplying.
yes.
Okay? So let's do another example. If I have a to the power of 12 times a to the power of 2, what do you get without expanding?
8 to 14?
A to the 14, right? Because 12 plus 2 is 14. Are we okay with this?
Bigger.
How about if I have 7 to the power of 4 times 7 to the power of 5? What do I get?
7 to the 9?
Do we ever get three numbers, like 7 to the power of 4, 7 to the power of 5, 7 to the power of 6? Or
Sure,
just-
let's try that.
Okay. I didn't have to do it, I was just.
Times 7 to the power of 2. Let's see. What do you get?
7 and 11.
Yes? So all what you're doing is you're adding your exponent. 4 plus 5 is 9, plus 2 is 11. Your final answer is 7 to the power of 11. Okay? So the deal with this, you have to have the same base. If you don't have the same base, you can't do it. So you have to have the same base, and you have to be multiplying. Okay?
So what if, so if you did, expanding by 7 times 4 to the 4 to the 5 to the 5 to the 7, and then, you got the total number,
Yeah.
that would be correct. You did say 7,749 times 7, blah, blah, blah.
If you do 7 to the power of 11, and if you actually multiply your 7 11 times, it's going to be exactly the same answer. Yeah.
It's more work, right?
Yes, it is. It's either you do 7 times 7 times 7 times 7 times 7 times 7 until you get to 11 times, or you do 7 and then you'd have, or whatever, x to the power of y, 11, you're going to get exactly the same answer. Okay. Now, I have almost the same deal here, but instead of multiplying, I'm dividing. Okay?
Is the answer 63?
For what? For which one?
7 to the power of 3 times
7 to the power of 11.
This one? It's way more than 63. Try it. 7 to the power of 11. Try it on the calculator.
It's like hundreds, isn't it? 7 times 7.
I want you guys to try it. Do it. Put it on the calculator.
1 billion, 9.
It's a huge number. You're multiplying 7 11 times.
So I can't remember what I did. I think I did like,
You probably are adding. You're probably adding.
I don't know. Oh, I was adding.
Maybe. Okay? Not multiplying. Okay? Now, let's look at this example. 2 to the power of 4 divided by 2 to the power of 2. What's 2 to the power of 4 again, if I want to expand? It'll be what? 2 times 2 times 2 times 2.
Yeah.
And then divided by, that's the same thing as this. And I have 2 times 2. Yeah?
Yeah.
Okay. Now, let's try to simplify this. You know that if I have something on the top and the bottom and they're multiplied, I can just cross them out. Okay? So if I'm going to cross, I can cross this 2 and this 2. Right? Because they're multiplication, I can do that. And I can cross this 2 and this 2, right? Do you agree? Or no?
Yes.
How did we cross it though exactly? Because there's nothing left
Because they
now.
simplify. What's 2 over 2?
So,
What's 2 divided by 2?
0?
1.
1.
Sorry.
Yeah, if you have 2 chocolate bars and there's 2 of us, we can each get 1, right? Yeah. So it's the same thing here. So what I'm doing is I'm dividing 2 by 2, which is 1. So I don't have to count it because it's multiplication.
Oh, I get it now, okay.
Right? Okay. Now what do I have left?
2 by 2.
2 by 2, which is what if I want to write as an exponent? What's 2 times 2?
2 to the power of 2.
2 to the power of 2. Good. Now, there is a rule for it. Okay? Similar to the rule of multiplication, there's going to be a rule for the division. Can you guess what it
Are
is?
we doing multiplication to get the division answer though?
No.
That's what it
Like,
looks like
I don't-
we're writing there.
Well, what I wrote here is 2 to the power of 4,
Just
so it's 2
read-
times 2
rewrite
times 2
it,
times 2.
Okay, okay.
Right? You okay with that?
Yeah.
Okay. Now, how do you think I got from this to 2 to the power of 2?
By eliminating all the numbers that are the same?
Mm-hmm. Now, if I want to make it easier and I don't want to expand, I don't want to do all this work. You see how when I was multiplying, I had to add the exponent. What do you think I have to do with the division?
Minus?
Subtract. Subtract. So, if you do this, 4 minus 2, you're gonna end up with the same answer. Okay? Let me show you letters because letters and I don't like the numbers.
Do the numbers always have to be the same, like 2 to the power of 4 and 2 to the power of 2, or can it be like 2 to the power of 7, 3 to the power of 6?
It can be, you have to have the same base. If you don't have the same base, you can't do it.
Okay.
Okay? So let's look at letters. So if I have a to the power of 7 divided by a to the power of 3. You see how I have the same base? Has to be the same base, otherwise you can't do it. So now the simple way to do it is subtract your exponent. So it's going to be a to the power of 4.
Division, you subtract.
That's right, subtract
Your
your
base is the
Exactly.
So if you have a separate base, you have to,
You can't do it. If you don't have the same base, you can't do it.
so you have to do.
Question.
You have to actually do the
the
work.
whole work.
Yeah. Okay? So let's say if you had this, you can't, there's nothing you can do. It's gonna stay the same. So there's
So
nothing.
that would even be a question then, or?
It can be, but not for you, like not right now.
Okay.
You know what I mean? Like it won't be something like this. It will be like something more complicated, and then you have to simplify, and it simplifies to end up like this. When you get to this, you can't do anything anymore.
Okay.
Right? Okay. So we know the two rules. Same base, and I'm multiplying, I can add the exponent, right? Same base, I'm dividing, I subtract the exponent. Now, you guys have your calculator, right? Put 2 to the power of 0 for me. What do you get?
1.
Did we all get one?
Yeah.
Okay. How about 99 to the power of 0?
99 to the power of 0?
Yeah? What did you get?
1.
How about 1,000 to the power of 0?
1, no? It's all the
Yeah.
same thing, isn't it?
Yeah.
Do you have any Advil or Tylenol or
Cold
any,
and sinus.
any kind of anything?
Cold and sinus?
Sure. Hit me with your best one.
So
Sorry,
anything to the power of 0 is 1. Even if it's a letter. And it's to the power of 0, it's going to be 1.
So anything to the power of 0 is going to be 1.
Anything to the power of 0 is going to be 1. Get that clear?
All ordinal numbers or cardinal numbers have that implied power of 0. It's like the implied new subject.
Don't take the white one because it's Tylenol, like most Tylenol.
Thank you very much. If anybody was recording that, stop.
Yeah, it's recorded.
I know it's recording and it's gonna be funny. Okay. Okay, so anything to the power of 0 is 1.
Why is it 1? Wouldn't it just be 2 or whatever?
Why is it 1? That's a very good question. Let's see.
Because it can't be 0 because there's a number to begin with, right?
Let's try this. 5 to the power of 3 over 5 to the power of 3. Do the regular thing for me. So if I'm dividing with the same base, what do I do with the exponent? Subtract, right? So that's 5, 3 minus 3, which is 5 to the power of
0.
0. Good. Leave that on the side. Okay? Now, I want you to find the answer for me for 5 to the power of 3 on the calculator. What's 5 to the power of 3 on the calculator? 125. So that's 125 over 125, right? What's 125 over 125?
0.
No.
1.
1. If I have 125 chocolate bars and there's 125 of us, each one of us will get 1. Okay? Do we agree on this?
Yeah.
Okay. Now, let's go back to the first one. So 5 to the power of 3 over 5 to the power of 3 is 5 to the power of 0. And at the same time, 5 to the power of 3 over 5 to the power of 3 is 1. So that means these are the same, right? Yeah? Yeah?
So 5 to the power of 0 is the same thing as 1.
Yes.
Okay.
Anything to the power of 0 is going to be 1. What? But do you understand how this simplified to 1?
Well, what is this a multiply? Is this a multiply or is this division or what is it?
Which one?
As to why 5 to the power of 0 is 1.
5 to the power of 0 is 1 because if I go back here, right?
Yeah.
5 to the power of 3 is 125.
Yeah.
5 to the power of 3 is 125, right?
Okay.
So 125 divided by 125 is, what's 125 divided by itself?
0.
No, 1. Anything divided by itself is 1. Okay?
Oh. Alright, I get it.
Now,
Wow,
can you
that's
correlate
right.
the two?
That's okay too.
Can we do that? Are we okay with that?
Yeah.
Let's read the next one. When finding the power of a product, apply the exponent to each number in the product. So much time. Okay. I'm gonna use letters first, and then I will explain this to you. Okay? Because with letters, sometimes it's easier when to see this. So if I have A times B, and then to the power of 2.
Resolve A times B, and then when you get that letter, you multiple, do their calculator to the power of 2.
That's right. So that would be fine for if I have the numbers. It will be 2 times 3, which is 6 to the power of 2. Okay? But if I have letters and I want to expand, okay, what happens is that 2 is going to go to each letter. Because I can't do A times B. There's no way I can find what A times B is. They're letters, and that's why I'm using letters now.
Yes, you.
So this is the same thing as writing this. Okay?
So it's just like an unfinished question. You have to finish it to figure out what the actual question is to answer
This
it.
is basically the rule. This is how the rule is, right? So if I have, let's say, if I have this, there's multiple ways that I can do it. I can do 2 times 3, as Danica said. 2 times 3, and then that would give me 6, and then make it to the power of 2. So that's 36. 36, right? Or I can do this. 2 to the power of 2 times 3 to the power of 2, which is going to give me this. 4 times 9, which is also 36. Okay? But the rule says, if you have something times something all to the power of 2, that 2 can be distributed for both of them.
What if,
So if the two's outside the bracket,
If the 2 is outside the bracket, yeah.
H power of 2, you double A batteries.
Are you guys okay with this?
Yeah.
Now, it's the same rule if I have division. Okay? So, if I have A divided by B, all to the power of 2, right? That's the same thing as doing A squared over B squared. So that squared is going to be distributed to both terms.
so
Okay.
what if you had, the base, where it's saying 2, back to that one, if we got 36? Yeah. To the right, yeah, what if we were 2 times 2 to the power of 2?
Then you could have simplified and it will be 2 to the power of 4. But in this case, they're not the same base, so I can't add the exponent.
So it's not, it wouldn't be 4 to the power of 4.
No, it will be 2 to the power. You don't, you keep the base the same. Are we okay with this? So if I want to do this, there's 2 ways that I can do it. I can simplify first, so 6 divided by 3 is 2, and then 2 to the power of 2 is 4. Or I can do 6 to the power of 2 over 3 to the power of 2. Right, so bring in the 2 in for each one, which is 36 over 9, which is equal to 4.
If you do it how you start with the A and B, there's no other way once you pass that?
No, that's it. There's no way that you can simplify
Not that way.
For which one?
for the A and B,
For
or that. Like that's it. You can't go any further with that. Okay? All of these rules, by the way, they're right here. These 4. And then the 0 is there. So I have this down here. Okay? Are we okay with this? Alright. Just 1 second, I'll come back.